I'm Ross Goodwin. Thanks for having me here. It's awesome to be here. This talk's called Narrated Reality. And I guess I'll get to that in a second, what that means. But first I want to play a quick game. And this game is called Actual English Word or Invented Gibberish. So I'm going to show you a word and a definition, and you're going to have to tell me whether it's a real word or a fake word. And the first one is bickerate. So raise your hand if you think this is a real word. A few people. Okay, who thinks this is a fake word? More people. Yeah, it's indeed fake. Okay, next one is pleborical. Real word? Okay, like half, maybe a little more than half. Fake word? A little fewer. It's also fake. Okay, next one is tautology. Real word? Like everybody. Fake word? A couple people. Can't fool you guys, you're all programmers. It's indeed real. And we have the last one is logistant. Who thinks this is a real word? One person, some people. Fake word? More people. Yeah, I can't fool you guys, it's fake. Or can I? Because you may be asking yourself, was that the real definition of tautology? And in fact, it was not. This is the real definition of tautology. The saying of the same thing twice over in different words. The definition I showed you was the study of the development of moral principles in the mind and the opinions of the process and the explicit processes of people. And despite the etymology and word endings, parts of speech, this is not a real definition. So where do these definitions come from? Well, they came from a bot I made called Lexiconger. This is a LSTM, recurrent neural network, long short-term memory, that's what LSTM stands for, trained on the Oxford English Dictionary. To get a definition for an invented word or an alternate definition for a real word, all you need to do is tweet at Lexiconger, followed by your invented word. And the full definitions are posted to lexiconger.tumblr.com. This is one of my favorite definitions it came up with was the one for love, which is a result of a person's or animal's response to a problem or difficulty. She loved the music of the new employee. Another version of the model said the definition of love was past tense of leave, which I found like equally amusing. Yeah, it's quite good at taking an arbitrary set of characters and interpreting those characters in the context of actual words. It's a character level LSTM, so it's actually writing and understanding language at the character level. So something weird happened with this bot, which is that I didn't set up the replies correctly initially, and Twitter flagged it as a spam bot, and its privileges got revoked temporarily. And I don't usually feel this way about my bots, but that left me feeling raw in a way that I wasn't expecting. I know it's not a person or anywhere near human level intelligence, but it might be smarter than certain animals. The way it can break down an arbitrary string of characters, as I said, if you end a word in ology, it'll oftentimes say the science of, capitalize words or register as proper nouns. Anyway, it felt like Twitter had killed my pet. And I also felt conflicted. Should anyone feel this way about a machine? What are the implications of that? Is this the uncanny valley of language? So before I go any further into my exploration with neural nets and computational creativity, I want to make a personal confession, which is that I used to be a ghostwriter. Not that kind of ghostwriter. So how that all started was I went to MIT as an undergrad, intending to study physics, and then I met this gentleman, Noam Chomsky. Started off by having lunch with him once my freshman year. A friend of mine was a senior who was asking famous professors on campus if they'd have lunch with her, which is a great idea. And she asked Professor Chomsky, and he said yes, and I begged her to let me come. And I asked him a ton of questions, and the last one I asked him was, can I work for you? And he said yes. So for the next 2 years, I saw him periodically, and we talked about politics and language. And I worked on a project concerning the foreign policy rhetoric of American politicians. And then I decided that I wanted to be a political speechwriter. So I got fairly far in that ambition. I took this picture on Election Day in Chicago in 2008. In June 2008, I moved to Chicago to intern on Barack Obama's presidential campaign at the national headquarters, mostly writing letters from then Senator Obama to respond to voters. but I also ghostwrote op-eds for prominent Republican endorsers, including Lincoln Chafee, who you might remember from the Democratic primaries in this past election cycle. Against my advisor's advice, I took the fall 2008 semester off of my senior year to work on the campaign through Election Day and on the transition team in Chicago and then in DC. And as a result, my first job out of college was at the White House, which was really awesome, as a presidential writer. So I started out as a junior writer, writing birthday and wedding cards and stuff like that. And I got promoted to writing presidential proclamations, which are like statements of national days, weeks, and months of things. They're also used for policy action. I think Trump just used one for his travel ban. But the ones I wrote were for national observances. Most of them are for national observances. So everything from Thanksgiving and African American History Month to things like Safe Boating Week. So as you can imagine, it was a really exciting job. I decided after doing that for a little while that I wanted like a real serious policy job. So I went to the Treasury Department to work as a special assistant for Secretary Geithner. Because I majored in economics, and like I said, I wanted a more serious policy job. This is me in the background of a documentary about the Treasury Department, just walking by. So I started to learn how to code at Treasury in order to automate the paper churning tasks I had to handle, like making binders for the Secretary and DepSec. And so I found that with a push of a button, I could print, hole punch, collate, insert dividers, etc. But I wanted to do more than make binders, and without any meaningful speech writing opportunities, I left and started freelancing as a ghostwriter, which was a different story entirely. So I did all sorts of unsavory work. I wrote letters for a mining company to government officials, ostensibly from concerned members of the local community, but actually all from me. This is something called astroturfing. You can look it up. It's a very common practice in American politics these days. So the letters would say something like, you know, we want this mine, your government red tape, meaning safety inspections, is killing jobs. And I did it despite being morally reprehensible because I needed the money. And it paid well because I found a way to cheat. I developed this technique I called horizontal writing, where I'd write in a spreadsheet and write all the first paragraphs of every letter, then all the second paragraphs, and then all the third paragraphs in groups and so on, in columns for each letter. And then every other day I'd run a simple Excel macro to rearrange the cells randomly and then edit them and hand it as a new batch of letters. So I was doing a job that was supposed to take 8 hours a day in like 2 hours, and I spent the rest of my time working on a novel that's still not finished. That's another story. So I turned this technique into a game with some friends. So we called it the diagonalization argument, inspired by George Cantor's 1891 proof of the same name, for the existence of infinite sets that cannot be put into one-to-one correspondence with a set of natural numbers. It's a really beautiful mathematical proof. So how this works is each column is a chapter. Each player fills the diagonal line of cells. New cells may only be written next to already adjacently filled ones. Player 1 writes the first paragraph of the first chapter. Player 2 writes the second paragraph of the first chapter and the first paragraph of the second chapter. Player 3 writes the third paragraph of the first chapter, second paragraph of the second chapter, first paragraph of the third, and so on. So it can be done with any number of players. And I thought I was onto something really new and innovative, but it turns out that people have been doing this for decades, literally, mixing writing and algorithms. And this is an example, Raymond Queneau, 100,000 Billion Poems, written in 1961, is a poem that's designed to be rearranged. Queneau was part of the ULIPO, which is the Ouvroir de Littérature Potentielle, or the Workshop for Potential Literature, which is a group that continues to explore the intersection of language and computation to this day. And that's just one of many examples of computational creative writing that have emerged over the, since probably the 20s or 30s. So my last freelance writing assignment, I was asked to review all the Python guides on the internet. And I thought, I might as well try to learn Python to make this guide better. And one stood out. It was Learn Python the Hard Way by Zed Shaw. And that was pretty much it for me. I didn't even finish the assignment. I just started coding, and that was it. In 2014, I started NYU ITP, which is the Interactive Telecommunications Program. It's kind of like art school for engineers or engineering school for artists. And I wanted to continue my creative work with computation and writing. So I did a bunch of projects my first year, but I want to sort of fast forward to 2015 to the first project in this that brought me to this narrated reality subject matter. And that was this project called word.camera. It was my first machine learning project. It turns images into strange prose poems. And I was using this API called Clarify, which returns a set of nouns from an image using a convolutional neural net, concept net database to find related words, and then a template system to sort of string those words together into sentences and paragraphs. And it was really about redefining the photographic experience. So how this came to be was that I received a grant in early 2015 from Google to produce a computer-generated screenplay. And I was thinking a lot about screenplays and how they're written. And if you know anything about writing screenplays, you know that only things that can be seen can be described. You never go into a character's head. So I thought, how do you generate a realistically descriptive scene? Well, maybe use photos in the corpus. So I got sidetracked with this project. I didn't end up making a screenplay generator at that time. But I really, fell in love with this idea of narrating images, because I think that image captioning is sort of a narrow view of what CNNs can do. It's useful as a benchmark, but not very interesting from a creative standpoint. And I think that fixation with captioning sort of constrains creative thought around possibilities of the technology. It also implies replacement of human function, which scares some people. So I thought, why not just caption image? Why just caption image? Why not narrate them? Why not try to write with a camera instead of a pen, and try to redefine the photographic experience? So the output was a little choppy at first. This is what it looked like. This is a young picture of Vladimir Putin. And the thing about computer-generated text is that it's often like a Rorschach test. You can see in it whatever you want. But that's also okay. Alison Parrish, who's one of my mentors, she's actually speaking here at this conference in the next slot at 3:10 about creative applications of Word2Vec. Has this great comparison of space probes and generative poetry programs. And what she says is that both space probes and generative poetry programs venture into realms inhospitable to human survival and send back telemetry telling us what is found there. For space probes, that realm is outer space. For generative poetry programs, that realm is nonsense. Humans generally shrink from nonsense, but a good poetic procedure can demonstrate that nonsense is worth engaging with. There are infinite undiscovered gems of language that lie hidden within nonsense's borders. So I also feel like grounding generative text in reality by using a photograph as input gives the text context, and that can often give it meaning, at least so far as I've observed in people's reaction to this work. So I decided to put this software inside of a physical device. So I made this series of physical devices with Raspberry Pis inside of old film cameras. Again, it was about redefining the photographic experience. I used thermal receipt printers to output text. And I wanted to build them inside of old cameras because I wanted to provide a reference that users could immediately understand and communicate that this is a primitive form of something. This isn't the Canon 5D. This is the daguerreotype. It's the first step in sort of in what could be a lineage. So it was just very simple, single button interface on the back. You press the button and a receipt comes out. Here's another one that I made. But the receipt looked like this. It was like a Polaroid, sort of, and there would be a number at the top, some generative content based on the photo, a URL where you could see the rest of the generative content because there was more of it that could fit on like a reasonably sized receipt, and then an epitaph, which would be a paragraph from a novel that was algorithmically matched to the generative content. Basically, I did that because I thought the text was kind of choppy at the time, and I didn't think it could really stand on its own, and I wanted to provide people something human written to go along with generative output. So I kept going with these in 2015, and then at the end of the year, I got access to NYU's supercomputer, and I started training my own deep learning models. I trained a number of LSTM recurrent neural networks on various corpora. Lexicondra was one of the first ones. But I also trained a bunch of models on poetry and prose. The output I got at first was really encouraging. It was stuff like this. So I'll give you a second to read that. I hate reading stuff when it's on the screen. This is curated, obviously, but it's indicative of the type of output I was getting just from training on large sets of poetry. So I also trained image captioning models using Andre Karpathy's Neural Talk 2 on Microsoft's Common Objects and Context dataset. This is some output from one of the first ones. And based on the way LSTMs work, where you have to actually seed them with some starter text, and then they sort of extend that, I thought, why not try to combine these two things and make a new version of word camera. So what I did was I started seeding my poetic language LSTMs with image captions. So this is one of the earliest ones I did. This is from a really early test. It says, "A man is sitting at the edge of the waters. I should see him begin to stand at the throat of the graveyard." And then it sort of descends into more nonsensical text. But it was still really encouraging, and I released some models into Creative Commons in a GitHub repo called Neural Snap, and some code under an open source license. And I made another physical device. This was what the first prototype in my thesis project at ITP. So it started out as one device that would use image captions, location, and time to generate text. And the concept was narrated reality, which was something that I thought might be kind of like virtual or augmented reality, but more about experiencing things as they happen, and then later in an augmented format. The goal of the project, the sort of dream idea, was to imagine generating a novel by taking a long walk in your city. I got some advice from this guy, Taiyun Choi, who's the founder of the School for Poetic Computation in New York. And he said it was just too much packed into one device. It was a little confusing. So I split it into 3 devices, a camera, a compass, and a clock, to narrate images, location, and time, respectively. And for all 3 devices, I used one of these NVIDIA Jetson system-on-chip computers, which is like a Raspberry Pi with a GPU, and a Datamax O'Neill microflash 4T printer, which is the same kind that police officers use to print your traffic tickets. So the system was totally autonomous, no internet connection was needed, and I decided to train a library of neural network models on it and put them on SD cards so they could be used interchangeably with each device. So here we have like tech news, sci-fi prose, sci-fi film, hip hop, film chat, which is like continuous dialogue, which I'll get to in a minute, folk music, 2016 presidential candidates, and Robot God, which was a mix of every religious text combined. So this is sort of how each device works. There'd be, that GIF did not start at the beginning. This is the clock, so there's a user interaction. That's funny, these GIFs usually start at the beginning of their GIF, but it's going to start right in the middle for some reason. So, like I said, this is the clock. You start by picking a model from the library of models. And then you basically put the SD card into the device's SD card slot like a video game cartridge. And there's a user interaction. And then you get the output, in this case, a narration of the time. And then for this device, I used a 1915 punch clock made by a company that was the predecessor to IBM. Which I think was an interesting reference for the piece in general. So the output looked like this. The time was 2 minutes past midnight, the corridor was a long corridor in the shadows, and the whole thing was the same as a wall, and the door slanted from the line of the wall. The sun was a dead wave of appearance. The moon had been dimpled, and a corner of the corner was silent, and the floor was like the sable pile of a flower. A cold road would be stronger. So, despite the only thing indicative of midnight being the seed text, which was a sort of natural language rendition of the time, the sort of midnightness trickles down through the output, and I really liked that about this particular example. This is the camera I built using the same guts displayed at the Phi Centre in Montreal. And here's some output from that. This is actually a picture of me standing in front of the clock, so very meta. And I'm using the folk music model for the output in this case. So this is trained on folk lyrics. The final device in the series was the compass, which was sort of inspired by war driving. Is everybody familiar with war driving? It's basically driving around with a computer in your car and hacking into Wi-Fi networks. But this is a friendlier version of war driving. I used the navigator's compass from a B-17 Flying Fortress and the center console from a police car. And it was designed to be mounted in the car, and you drive around and it would generate text based on your location. Originally, I wanted it to generate plausible car accidents, but I thought that was a little bit too dark. But yeah, that's that piece. And I didn't get to test it at ITP, but I did get to test it this year, and I'll get to that in a few slides. But the output looked like this. So this is one I took it just at NYU ITP. And this is the model is one of the screenplay models. So here's all three devices together for the first and only time at my thesis show at ITP. They've never all been together again in working state. The fun thing about neural nets, I mentioned before that last sample was from a screenplay model or a dialogue model from screenplays. When you train on continuous dialogue, you can actually ask the model questions. So this is one of the questions I asked it, one of my favorite responses it gave me, which is, where did you grow up? But yeah, I didn't have to do that. And the reason I was training on screenplays to begin with was, going back to the original reason I had received that grant from Google in 2015, which ended up sparking word.camera, which was to make a computer-generated screenplay. And I ended up doing that in 2016 with an LSTM and made this film called Sunspring. So I made Sunspring with a film director named Oscar Sharp in April 2016 for the Sci-Fi London 48-hour film contest. I met Oscar at NYU. We were both in a class called Surveillance Documentary, which was a joint class between ITP and the film department. And he gathered an incredibly talented group of actors, including Thomas Middleditch from Silicon Valley and HBO. And so far as we know, it's the first film created from a computer-generated screenplay. If anybody knows of a prior example, please let me know, because we've been saying that for a year and nobody's challenged us on it. The whole film was written, shot, and scored and edited in 2 days, and you can watch it for free on YouTube. It's about 9 minutes long. And we had an advantage in the contest because other teams had to spend their whole first day writing, and we didn't have to do that. So you can watch, like I said, you can watch it on YouTube. But the LSTM wrote the action description as well as the dialogue, which results in really surreal sequences like this. The line from the screenplay was, he pulls his eye from his mouth. So that just happens in the middle of the scene. And it's sort of reminiscent of a lot of surrealist cinema. But I've never seen anyone do this in a movie before. And I really like this scene, but I like the next scene more. So in this scene, the line is, he pulls the camera toward his back. So he physically pulls on the camera, but then the angle changes and he's holding nothing. And to me, that's really indicative of the cycle of generation and interpretation that this sort of exercise lends itself to. So while the action of pulling on the camera was dictated by the machine, the angle change and him holding nothing was a human interpretation informed by years of film production experience, which I thought was really brilliant. And these little gems can come out in that dialogue you have with the machine. So for the Sci-Fi London 48-hour, we also made a short story for the Flash Fiction contest. You can read the whole thing at that URL. I'll just read you one quick passage from it. "I'm the one who wanted to be a millionaire," says Mindy. "I know you're a good man," she said. Mindy Mandible was a person who was still alive. It was a transient and superior thought that was shameful. It was too heavy for her, but there was no way of standing beside her. It was a sense of astonishment, and it was the panic of a mind, and that was a muscular and almost familiar reason. So, like I said, if you curate the output from these machines, you get wonderful passages like that. And it doesn't take that much curation, honestly. More recently, I've been working on a lot more projects with deep learning. This is one of them. It's called Unasked Questions. I can't claim credit for the design on the back of the card. This is just a graphic designer's mock-up of the project. But the idea is that I collected questions from Ask Reddit for like a year. Every question posted to Ask Reddit. And I have over 1 million, and I trained a neural network on those, and now it writes new questions in that style. So I'll read you a few of those. What did you think you were doing on the internet but turned out not to be? If you had to choose between Trump's hands and final death for you, which would you choose and why? What are some myths that you would like to share with North Korea? What is your favorite cheese distraction? If you could go back in time, what would your social media post be? What is a product that likely starts in a dangerous time period? Why are millennials so ashamed of men? And what are some really good names for a straight guy? So the idea behind the card deck is that it would be an infinite set of cards where every card in every deck is unique. Still looking for someone who can actually achieve that with printing technology. But I'm hopeful about producing this project in real life and not just as a graphic designer's rendition. But that's in progress. Another project I'm working on right now that I've been working on since late last year is I wore a lavalier mic, sort of like the one I'm wearing right now, but on my coat for 2 months and recorded everything I said. And I isolated it so that it didn't pick up people around me, and I had to basically preface every conversation I had for 2 months with, I'm wearing a wire. But the idea is that I'm gonna run speech to text on the output or on that audio, and then train a neural network on the transcript, and then delete the audio, and then have a bot that just talks like me forever, and put that in a mannequin. So that's in progress. A sort of recently completed project is this project WordCar. So I've been really fortunate to have gotten involved with Google's Artist and Machine Intelligence program, which is a fairly new initiative from Google. And they sponsored this project. It's called WordCar, and what we did was drive a Cadillac from New York to New Orleans, and the car had a pan-tilt zoom surveillance camera on the rear trunk, a GPS unit, and a microphone to pick up conversation, and it was basically the realization of that Compass project I mentioned before. So it was really cool, and hopefully the book is being published actually with a French publisher called Jean Boit that publishes computational creative writing. So I'm really excited about that. And we drove to New Orleans because I wanted to meet this guy named Josh Sniffen in Biloxi, Mississippi. Josh builds custom PC gaming cases, and he is helping me build a new set of word cameras that will be a little bit more professional looking than the ones I built myself. So this is one that is almost finished. It's inside of an 1885 large format camera, and the idea is that the entire computer is contained within the camera, rather than the previous ones that I showed you that were either driven by Wi-Fi, or had the prior version of the software on it. This has the newest version of my word camera software, which actually requires a bigger GPU than the NVIDIA Jetson has. So yeah, that's what's running inside the camera. And we made a follow-up to Sunspring this year called It's No Game, also on YouTube, starring David Hasselhoff. So for this movie, Oscar and I, we curated the output more. And we also I trained not just one model, but actually 5. I trained one on, and they're all trained on subtitles. There's this wonderful website called Subscene, which is sort of maintained by the deaf community. And it's just a treasure trove of every subtitle from every show and movie you could possibly think of. So I got all the subtitles from Baywatch and Knight Rider and trained a model for David Hasselhoff. We did a Shakespeare model, we did an Aaron Sorkin model, a Golden Age Hollywood model, and a generative ballet model, which wasn't even a neural network. It was a context-free grammar designed to do generative ballet instructions. But watch the movie, it's on YouTube, also like 9 minutes long, also made for the Sci-Fi London 48-hour film challenge. And you can decide for yourself. So I want to close with a couple of demos. I have here a version of Word Camera. This was on display at the Science Gallery in Dublin, Ireland for like 3 months, so it's a little beat up. But this one, the computer's inside the camera, just connects to my laptop via USB. And I'll just take a picture of everybody here. And you can see it prints out on the back like that. Does an ASCII version of the image first. Okay. So what it says is, lights on the ceiling were already standing before him, and the sheets of water came into the barn, and the snow stood in the street where the wind was blowing and showed the tracks of the buildings. People in the background came to a party. A boy came in from the bedroom and without music. A sign on the side of a building was being turned off. A black and brown shelf was still shut. A large design on the table was locked, and it always seemed to him that he had been to the city office to carry the book on the table and finally started to spend the night in the corridor. So that's an okay one. Not exactly, as connected to the image, but the thing is there's a lot of stuff in the background and you can't always control what the computer is going to want to talk about. So I guess I'll take one more just of myself so I can show you the difference. Wow, it didn't mention me at all. Let's try this one more time. Well, there we go. Something has gone wrong. No, there it goes. Nope, I'll just restart the script. 1 second, folks. Okay, like I said, this was on display for 3 months. So I'll just read it off the screen, as it is showing up. Now it's working. Okay, that was not a picture of me, it was a picture of that, but I'll just read it. A large black sign was standing beside him, and a car ran through the grass and the point of the bushes and the hooves of the barn that had been transported into the front door. Alight on the bushes was a cool basin and a snapping cardboard and beans with colored cloth swaying in the moonlit light of the trees. A round mirror on the wall was the size of a door that had been given to a carpet and a little patch of carpet that floated above the counter with a long black pin. A small white tablet came to a stop in the middle of the street and was fixed to a shirt, and a bright blue breeze was clutched to the sky. A wooden table was filled with rain and dried bottles. So I got one last demo, which is for, oops, it's coming off. This little app I'm building called Dialog, which is basically autocomplete for creative writing. I'm just going to mirror my screen. we go. That is way too... the joys of connecting Linux laptops to projectors. Okay, there we go. So, make this a little... So the idea behind this, oh, come on. Come on. There we go. Nope, switch. I'm just going to put this on the other screen, whatever. The idea behind this is that it's, there's two models that you can switch between. One is trained on all the paragraphs from Project Gutenberg that mention art and culture, and one is trained on all the paragraphs from Project Gutenberg that mention science and technology. So I'll start with the art one, and I'll say art is... Can't read that myself, so you're going to have to tell me what it says. Art is saying... So I'll switch to the science technology model. But, let's see, go back to arts and culture and see how it ends it. And there's this nice thing at the bottom where you can change the LSTM temperature. So temperature, if you're not familiar, is a parameter that controls the riskiness of the model's predictions. High temperature results are going to be more variable, but also more riddled with errors. Low temperature results tend to be more grounded, but also more repetitive and less interesting, smaller vocabulary. So let's turn up the temperature and see what happens. So when you turn up the temperature like that, it oftentimes will make up words, make up new proper nouns, insert words that you don't expect. So it's a really fun tool to play with. So that is all I have. And I'll just end with this deep dream GIF. Thank you.